The broadcast is now starting. All attendees are in listen-only mode.
Good morning or afternoon, whichever you may prefer, and welcome to the National Concrete Pavement Technology Center's Concrete Overlay Series. We developed 5 one-hour webinars to be offered each Tuesday at noon Central through May 5th. We hope that you are staying safe and protected in this unprecedented time in our history, and we are certainly pleased that you have chosen to join us to learn more about concrete overlays in this socially distanced manner. We all know that our travel schedules and our traditional ways of transferring technology has changed significantly in the past month. As one of the nation's premier resources in the art and science of concrete pavement knowledge, we truly appreciate the willingness of those who have provided sponsorships over the years that enable this outreach today and for the next coming weeks. My name is Gordon Smith, a moderator for today's session. Dr. Peter Taylor, as director of the CP Tech Center, will be enlightening us with an introduction to concrete overlays, and Dan King of the Iowa Concrete Paving Association will conclude our session by sharing the Iowa story about overlays. In the sessions that follow, others from around the country will relate their own overlay stories. While our group today is in excess of 500, much to our amazement, we are far over what we had anticipated, and unfortunately, we're limited to that number around 500. In that manner, we wanted to let you know that we will be rebroadcasting this on Friday, this coming Friday. We realize that that's Good Friday, and many people may not be working, but will also be available on our website, cptechcenter.org. Please feel free to offer any written questions that you might have, and we'll either answer it today or follow with a review of questions and answers by email. The presentation should be completed in approximately 1 hour, but we're willing to stay around to address some of the questions until 1:30 if you would like to remain on the line. Just a word or two about the CP Tech Center. The National Center offers concrete paving a lot to the concrete paving community. It was established at Iowa State University as a national center in 2005, and we serve as the nexus of the public agency industry academic partnership relating to our interest. We provide valued informational resources and act as a conveyor of concrete pavement technology through various mediums and activities, working with agencies such as the Department of Transportation, Federal Highway Administration, our DOTs around the country, and certainly with the industry and academic communities. Our professional staff includes Dr. Taylor, myself, Steve Treach, and John Adam, each of us having worked during our careers with at least one of these 3 foundational partners. Today, Dr. Taylor and Dan King will join us to present an introduction to concrete overlays and an Iowa overlay story that illustrates the one instance of expanding use of concrete for pavement rehabilitation or resurfacing needs throughout our nation. In the coming weeks, we will cover an overview of concrete overlays and the information they need to evaluate and select an overlay. We'll talk about concrete overlay design, plans and maintenance of traffic and construction. And finally, in our last session, we'll focus a bit on maintenance of concrete overlays and cover some of the resources that are available to you. As mentioned before, throughout the seminars, we'll be offering examples of how concrete overlays are performing around the country. So with that, welcome again, and Dr. Taylor, the proverbial podium is yours.
Thanks very much, Gordon, and thank you to all of you for joining us. It's kind of crazy to think speaking to 413 people at the same time from all over the country. So Yeah, this is a whole new experiment, an experience for us. Please bear with us as we learn how to do this. And as Gordon said, there is at the bottom right-hand side of your Adobe system, there's a little box called questions. Feel free to type your questions in there. And at the end of the presentation, Gordon will be reading those out, and any one of us three will attempt to answer them. So our purpose today is to do a fairly quick and dirty overview on this whole area of overlays. Why do we bother doing them? What do they look like? How do they make our lives better? Do they work? Not going to get into too much detail. This is a bit like driving at speed on a dirt road, just bumping over the high points. And then over the next 4 weeks, we will get into more detailed and get people who know about each particular topic to come and speak to this group. So the pavement system in the US was constructed, but the bulk of it was constructed and set up many years ago, and it is getting tired. It's some of it's pretty old, some of it's pretty beat up. Budgets for maintenance have been very limited for the last few years. And as we're starting to think about asset management, starting to realize that if we let the condition of a pavement fall too far towards the floor, the actual cost of restoring it to some sort of usable state can get very expensive very fast. So that the idea behind this graphic is that if you spend money relatively early on, you can maintain it pretty easily. If you let it get further down, the amount of money you have to spend increases fairly significantly. And this is not only true of pavements, but just about anything in our lives. Is, think about the vehicle you drive. Why is it that rental companies dispose of their cars after 30,000 miles? Is because the maintenance costs start to get too heavy. In my own vehicle, it's more cost effective to spend money on it and keep it in good condition rather than let it get to be really bad. So as we think about how to maintain and restore the condition of our pavement infrastructure system, we have a number of options. Our roads are getting old. We can toss them out and start again. In some ways, this is what we do with a lot of aspects of our lives. In a plastic disposable community or culture, it's part of the way we think about a lot of stuff. But does that make sense when we're looking at pavements? The benefit of this approach is that it's a long-term solution. We've got 30, 40 years out of the existing system. Toss it out, throw it away, put in a new one, we'll get another 30, 40 years. But there are some fairly significant negatives. What do we do with all of that material? If you think of the quantities of concrete, asphalt, rock, sand, foundation material, the volumes are huge. It's also not very sustainable. It burns a lot of energy, a lot of diesel, a lot of carbon dioxide footprint to pick them up, break them up, get them out of the way. And again, then we still have the carbon footprint of putting the new system back down. This also takes time. It's probably the longest and slowest approach to doing any form of rehabilitation. The photograph is actually taken from a stretch of highway near where we live right now. And it was on the road that we used to go on at least once every month, heading up to visit my daughter in college. And, we spent months beating up the old road, digging it out, getting it out of the way. And, the system was shut down basically, or constricted for months as we went through the whole process. And so, the social impacts are huge. The environmental impacts are huge. The costs are huge. So in terms of sustainability metrics, this is probably not the best approach that we can take. So the next alternative that we can think about is patch them, slap a bandage on them, and do something quick and dirty. Now, the benefit of this is that it's very little amount of material, energy and traffic impact is low. You can get in, do it overnight or over a day or two and get back out. The negatives, it's a short-term solution. It doesn't last very long. It's pretty unreliable. Smoothness is poor. Aesthetics is poor. So we, again, there is some positive, but there are also a lot of fairly significant negatives. So the third alternative we can think about is the one that we're going to spend the rest of today looking at, is the idea of an overlay. Put another layer on top of the existing system. The benefits of this is that the equity that we have of the system that's on the ground, we keep. It doesn't get disposed of. It's not wasted or thrown away. We're taking full advantage of that system regardless of its condition, and I'll talk about that in the next few slides. This seems to be the best way of maximizing our sustainability benefits, in that we're putting down as little material as we needed. We're not throwing away much material. The other issue, or the other benefit of this approach, is that we can actually design it to deliver whatever lifetime we want out of it. If it's just a case of buying a couple of years until the next planned maintenance cycle or next replacement cycle is budgeted, we can design and deliver a system that's going to last 5 years and probably not much more. The alternative is this: if we want this to be a long-term system, we can also do that, and we can make it serve for another 20, 30, 40 years as needed. The downside of this is that in urban environments, the elevations, connections, sidewalks, manholes, bridge clearance, those can be a little tricky. And so we do have to stop and think about these a little bit. When we're out in the middle of an Iowa cornfield, this is really easy. But if you're in an urban setting, this does become a little bit more of a challenge. However, this has been thought through. We do have suggestions on how to address this, and I'll touch on these today and go into more detail on them in 3 or 4 weeks' time. So, the message we're really just trying to put out there is that there are occasions when overlays may not be ideal, but for the agencies in the audience, this is just another tool in your toolbox for you to consider as you look at your maintenance issues going into the future. So, how do we classify overlays? And this is a topic that's still evolving. There is a lot of debate. There's been a flurry of emails circulating among those of us involved in the community over the last couple of days of how do we stop and think about and design overlays and the different systems that we may want to choose to do. Well, the first question, as an agency to ask yourself is, well, what's already there? Is it asphalt or concrete or a composite? That's pretty easy to answer. Go outside and kick it. And that's your first sort of bifurcation point in your decision tree. The next question is to ask, is that existing pavement in reasonably good condition? Are we doing this in order to just elevate it a little bit? Are we trying to improve traffic access? Are we trying to do a little bit of widening? If the system is in pretty good condition, that's a different approach than if the system is badly beat up and is looking pretty sad. Now, generally, the way that we're approaching this is that pavements that are in pretty good condition, you can consider a bonded overlay, meaning a system that is glued to the existing pavement. An unbonded system goes on top of systems that are in pretty sad shape. And the difference then is that in a bonded system, the old pavement becomes part of the structure. In an unbonded system, the old pavement is part of the foundation. And that has implications on the way that we design them. Now, it's pretty a simple way to think about it when we talk about concrete on concrete. It is a little bit blurry when we start talking about putting concrete on top of asphalt. Now, the fundamental science behind this decision process is that if you have two different systems, two different layers, stressing one that is not bonded to the one below can end up with fairly high stresses both at the bottom and the top of the, if we treat it as an elastic system sitting on a flexible medium. There is no connection between the stresses between the two. There is no shear between the two. Now, if we put a bond in between so that these two systems are working together, you can see that the stresses are actually reduced and some of the load is transferred into the existing system. That means fundamentally we can reduce the thickness of this concrete overlay. So there is an implication, are we putting it on good stuff or on bad stuff, does affect how thick the layer has to be that we're putting our new layer, or how thick that new layer has to be. The other thing that we have to think about then is that if it's bonded or unbonded is what do we do about the interface between the two layers? If we're doing an unbonded system, that new layer must not bond to the existing concrete. And the reason we get excited about that is that generally any cracks or joints that are in the existing system will reflect through into the new layer unless you can provide a separation. Again, unbonded systems tend to be being put down on poor condition and are slightly thicker. Now, when it comes to asphalt, some bonding is okay. We don't take any special activities to try and separate the two layers. So some bonding, this is where I said it becomes a little blurry in these definitions, but this is still as good a way of approaching or classifying these systems as any we have at the moment. On a bonded system, again, because we're decidedly or deliberately depending on the load carrying capacity of the existing system, that bond has to be there. We have to be able to transfer shear between the two layers. And this can prove to be a challenge, and I'll talk about how we prep the service a little bit later on. And there have been examples where failures have occurred because that bond hasn't been everything that we wanted it to be. For the existing asphalt, generally the thought process is that the existing asphalt has to be thick enough, or the foundation system that the asphalt is sitting on has to be pretty good. If the asphalt gets too thin and you're sitting on a very flexible layer, like straight on clay, it's not going to perform. There just is not enough meat in the system to carry the loads. The other issue is that, again, for the condition of the existing layer must be pretty good. As I said, we are still among the community are discussing and refining ways to help simplify the way to think about these, and this will be adjusted in future editions of our publications. But this thought process is still reasonably valid, and some of the details on how it impacts design will be discussed in a couple of weeks' time. Expected service life, basically it depends on the thickness. Thinner pavements generally, or thinner overlays generally, last a little bit shorter life. 15 to 25 years have been recorded, and Dan will be talking about that towards the end of this session. If you go in for fairly thick sections, you can easily get more than 20 years out of an existing pavement. In the photograph, Grundy County, built in 1978, and is still looking very sweet. Now, admittedly, that's a rural roadway and doesn't see a lot of traffic, but it's there, it's looking good, and it's carrying that traffic perfectly satisfactory. Now, again, all of this depends on whether or not the design was appropriate, and it also depends on how well it was built. So again, there is a need for us to do good engineering. It is tempting to talk about, let's make it simple, let's apply a few global rules of thumb. And I'm not convinced that is ideal. We are engineers, we should be applying engineering principles to the systems that we're trying to work with, taking the best advantage of what we have on hand and maximizing the efficiency of the systems that we're going to be putting down. So the big picture. What are we doing? First trick, get out there and have a look at the existing pavement. What sort of condition is it in? We've got guidelines, and again, we'll be addressing this in more detail next week, but look for damage, look for raveling, cracks in joints, look for faulting, look for indications of damage in the foundation layer. What is the condition of the pavement that is in place? If it's really bad, we need to be looking towards a thicker system. If it's pretty good and we're just doing a slight improvement, then we can look at a thinner system to go on top. Having got that information, then we can start talking about the design approach. How do we decide how thick to make this new pavement? Also, again, when we're sitting in an urban environment, start thinking about how do we do the connections to existing driveways, curbs, and that sort of thing. If needed, get in there and do some grinding and repairing. You know, I've talked at length about the existing system and has to be in pretty good shape. Now, one alternative may be, and I've seen this happen, we did a site visit last year to a city where a limited amount of repair work took it from being pretty sad to being in a position where it was ripe for a thin bonded overlay layer on top of it with a fairly small amount of grinding and repair. And again, the decision on this has to be economically based, along with taking into account things like traffic, time, sustainability, those sort of things. But a grind, patching some of the, if there are a limited amount of flaws, filling those up and repairing them is a necessary step. We prepare the interface. I'll talk about that in a couple slides. Do the paving, and then do the curing, cutting the joints, striping, and get it back open. It's not a very complicated procedure. It's been done in all sorts of settings and very successfully. How do you design the thickness? There are all sorts of tools out there. ME Design tool from Ashto includes a module developed by Julie Vandenbosch. Pavementdesigner.org, the PCA, ACPA, NRMCA program has a module in it. Some people revert to Ashto 93, and there is a commercial software design package called OptiPave. All of these tackle the problem in slightly different ways, and they're all appropriate in certain settings. Again, we'll be providing a lot more detail of how to tackle that in 2 weeks' time, and I'll move on quickly before I get myself into trouble. What about things like manholes and box outs? Again, guidance and information is available. It has been done. We have the tools available to help us do this sort of thing. That if you have a manhole, putting some adjusting rings into it will allow us to put another layer on top, put a new manhole on top of that, and keep on going. So these things don't make it impossible. It just means we do have to stop and think about it a little bit. What about the curbs? There are several ways we can tackle this. We can leave the curb in place and do a little bit of milling. We can remove the curb and replace it. We can remove the curb and gutter and replace that, or we can just build on top of the existing curb again. It depends very much on the system and the alignments and the needs that you have. And again, maybe the condition. If the existing curb is shot, you may not want to keep it. So again, good engineering, but the guidance on how to think about this is available. Transitions, how to go to meet up with other lanes if we're not overlaying the whole system. What about sidewalks and, not sidewalks, but shoulders? So again, some guidance is available on how to do those sort of things. When we talk about doing some repairs and surface preparation, again, if you have deteriorated joints, we may have to fill those up. If there is spalling, we will have to patch those. We do have to ensure that if the existing system as a load transfer, we have to put that back because, again, the whole design is built around the concept of loads being shared between adjacent panels. And then we also need to look at the surface. If we're looking for a bonded connection between the two layers, what we found is that the best way of preparing that surface is a grind, just to make sure that there is a roughness, that there's no loose material on the surface. It has to be clean and reasonably smooth. Well, smooth in terms of long wave cycles. It must be rough in short metrics so that the new concrete has something to bond onto. Then we look at the separation layer. If we're going with an unbonded system, that separation layer is absolutely critical. And its purpose is to, again, prevent cracks from reflecting from the old damaged pavement into the new layer. It also provides a bit of a level surface for the new concrete to go onto, and it also helps to provide a little bit of cushion. You can see from the image on the left that if there is some faulting or continued movement of the old pavement, that it's not going to cause any damage in the new surface layer on top of it. So again, that slight cushioning, the ability to absorb some deformation, and to provide a shear break between the two layers. If you're going to do an unbonded system, you have to do it, and it's important that it's done correctly. How do you do it? Two different ways. One is to throw down a layer of asphalt, typically about 1 inch of fresh asphalt. It acts as a relief layer. One of the advantages of taking this approach is that if you have fairly significant faulting in the old pavement, this can help absorb some of that faulting and prevent that from showing through onto the new pavement. The thing to watch out for is the risk of stripping of this new asphalt layer. And so it is absolutely critical that if you're putting an asphalt down, it has to be well drained. And that drainage means it's got to go somewhere. I remember seeing a pavement a few years ago where it was a mill and fill, had ground out some of the old material, put an asphalt interlayer in, put new concrete on top of it, but the water had nowhere to go. And so the asphalt had stripped, disappeared, and now the concrete had nothing to sit on. And we were able to make the new concrete overlay jump up and down. You could get little spurts of water coming out of the joints because the asphalt had failed, particularly under heavy truck traffic. The alternative is to consider using a geotextile, very much simpler to place. It is cheaper. Again, the drainage, it's very effective at draining any water that gets through the system. But again, it must have an outlet. It's got to go beyond the edge of the pavement system and into edge drains or into the shoulder if it's a fairly permeable shoulder. The water's got to have somewhere to go. And this is not surprising. I mean, I remember 30, close to 40 years ago, the first transportation lecture I remember sitting in second year college, professor stood up and said, water is the death knell of any pavement. This is not new information, but we do have to bear it in mind as we're designing our systems. If water gets through the joints, water gets under the pavement, it's got to have somewhere to go. We've got to get it an outlet. The one downside of the geotextile is it doesn't accommodate faulting and keying very well. And there is some debate among the community about how much does it move and is that significant. And that one we still need to do a little bit of research on. But these have been used fairly extensively, and as far as I'm aware, the performance has been pretty satisfactory. What about the concrete? What are we going to build these overlays out of? Everything that you've already built, your existing pavement systems. It does not have to be a special concrete mixture. In the same way that we suggest that for pavements in general, control the water cement ratio. The numbers we like to recommend is in the order of about 0.42. If you're in cold states, enough air. Super air meter of about 0.2, 0.3, total air content above 5% behind the paver. You must have enough supplementary cementing materials in the mixture to deal with the environmental issues, alkali-silica reaction, sulfate attack, chlorides, oxychloride de-icing salt attack. And again, also just because SCMs help us with long-term permeability, with strength, and again, with the sustainability issues that they have a lower environmental footprint. Let's take advantage of those. We're also recommending for all pavements, overlays, and others, control the gradation of your aggregate system. By doing that, we can minimize the amount of cement we put into the system. And that's a good thing, again, from a carbon dioxide point of view, from a cost, from a shrinkage, all sorts of benefits from putting in enough cement to get workability and properties, and no more than that. Excess cement is a waste of money. So the mixture is nothing different from an ordinary concrete pavement. What about joints? How big do we make our panels? It depends primarily on the type and the thickness. Generally, for bonded systems, we have to go with smaller panels because we're putting in thinner panels. I've seen them as small as 2 foot, and those look pretty crazy. There's one near where I live, and the joints are starting to ravel out from oxychloride attack. It's not a very pretty drive. It's 15, 20 years old. It's lasted remarkably well. But yeah, maybe that was a bit extreme. One of the issues with having smaller panels is, from a design point of view, it's always a good idea to keep the joints out of the wheel path. And so, again, part of the design consideration is, where are your joints going to be? The other key point is that if you're doing a bonded system, you have to cut full depth, particularly if you're cutting over an existing joint. You have to match up the new joints with the old joints so that you don't get reflective cracking. And you have to cut it full depth because if you don't cut it all the way through, then come summer and everything starts to expand, it hasn't got anywhere to go. And so the risk of blow-ups goes up pretty high. On unbonded systems, again, it's all tied to the thickness of the slab. Typically, if you want a rule of thumb, 6 by 6 by 6, 6 inches thick, 6 feet by 6 feet in dimension, has been used in many locations and has been used very successfully. Saw cut in this case can be T/3 because, again, we have separated the system from the layer below and we're less concerned about that differential movement. So standard T/3 saw depth can be perfectly satisfactory. In thicker systems, typically the rule of thumb we've been talking about is, if the slab is less than about 6 inches, you don't need dowels or load transfer in the new layer. If you're going bigger than 6 inches, then you probably do need some sort of load transfer devices. The point to note that we're really highlighting in this slide is that if you're using dowels, pay attention to how those cages are secured to the existing system. We have seen several cases where the concrete, as it's being dumped and pushed by the paving machine, has moved these cages a long way, and then they're not doing us any good at all. So nailing these things down properly is a little bit more challenging when you're trying to nail into concrete or asphalt, but it has to be done properly. Do we do this under traffic or do we divert? Yes, we've done both. This is taken from a construction site in Iowa. The things to note is that safety does become an issue. In this case, there was a 24-hour pilot car, so that traffic was controlled one way, alternating over fairly short intervals with the pilot car, but going backwards and forwards. The pilot car kept speeds down to about 25 miles an hour. And again, this is primarily for the safety of the construction crew. It did limit the amount of traffic that could go through this area. And in fact, what we found was that a lot of people, the local farmers, chose to divert and go around on other county roads, and the loads on those other county roads went up fairly significantly and irritated the county engineer quite a lot. Space for the construction crew is important. So again, when you're doing your design and your detailing, think about, do you have enough room? Do you have wide enough shoulders? If the traffic is going to ride on the shoulder, are they going to be able to get by? Is there enough space? The other one that we found on this one was that we were limited because of the pilot car to a 6-mile staging, and that it ended up with a fairly complex system of when we could pave westbound and eastbound in fairly short sections on what was, I think, a 30-mile reconstruction job that we did here. But it can be done. This one was pretty successful. There are no real issues with it. On the other hand, consideration can be given to just shutting it down, doing it all in one quick go, and getting out. And the feedback we've been getting is that this is a lot faster. It takes far less time to get in, work efficiently, and then get out. Without traffic blowing around the place, the safety for the operators is a whole lot better. Traffic control is a lot simpler. What does take a lot more effort then is public relations. And the suggestion is get your contractors to take charge of your communication with the local populace, because they can be pretty imaginative about, how do we provide access to your driveway if we're going to be shutting you down for a period of time? How do you get your products, particularly in a farming community, how do you get your products to market if the roadway is shut down? How do we get people to their houses? I live in a cul-de-sac populated by grumpy old professors, and the reason the city has never done anything with my street is because all of the grumpy people refuse to let them shut it down for more than about 20 minutes at a time. Communication would help resolve a lot of that. One of the innovative tools that has helped a lot has been this idea of stringless paving. If you go back to this image where we did the construction under traffic, you'll notice there is no string line. And so we were able to put in a far tighter work zone because we didn't have to have an extra couple feet for the string line for everybody to trip over. And this is because of stringless paving. Having predetermined 3D models of the whole system, GPS and total station controlled systems, you can see the masts on top of the paver here are talking to the GPS. It's all computer controlled, has been pretty effective. What we found is that most of the contractors that have used the system on a trial basis have discovered that their smoothness goes up, which means their ride bonuses go up. And so it's become cost effective for them. It does take a little bit more effort on the front end to get the design and the models in place. But again, the expertise and the tools are available, and guidance is readily available to the consultants that need this information. Having put the pavement down, my hobby horse, let me jump on my soapbox and rant about the need for curing. Concrete is a material that has to hydrate. You have to keep the water inside it as long as you possibly can to get all the benefit out of that expensive cement that we're putting into the mixture. So curing is not optional. Keep doing it. What about some new and innovative ideas that we're looking to in the future? One of the ones that we built last year was to look at the idea of fibers. So a county engineer agreed to let us put down an unbonded overlay with a far higher dosage of fiber than we usually do. His tradition, for the bulk of the project, it was 6-inch panels, 12 foot in squares with a geotextile interlayer and unbonded pavement. and he used 4 pounds of structural synthetic fibers for the whole project. For a short 600-foot test section, we doubled the amount of fiber. We had to increase the cement content slightly to keep the workability of the system alive, but we did not cut any saw joints in that 600 feet. The pavement, we didn't cut any transverse joints. The longitudinal and shoulder joints were cut as usual, but no transverse joints. After 11 days, we found that the cracks had formed at about 70 feet spacing. This was last fall. Dan can talk about this a little bit later, but he went back out there fairly recently, and I think we're running at about the same number of joints. Some of them have opened up a little bit, but the county engineer still seems to be pretty happy with the system. It saved us money on the saw cutting, and it seems to be performing pretty well. We'll be watching this over time to see how it copes with we've been through a winter, and now we need to go through a hot season and a wet season to see what happens over time. But interesting little experimental section. The fibers certainly helped. What happens with the joint-free section, who knows? We'll watch that one fun. We'll report it as time goes on. The other technology that I'm pretty excited about is internal curing. This is the idea of putting lightweight, fine material into the concrete that are pre-saturated. They help provide water to the hydrating cementitious system over time. And the benefit to that is that theoretically we would reduce the warping, how much movement is happening in the slab due to differential moisture profiles. We've built 2 sections, also in Iowa, 2 different counties. We put in quarter-mile sections with internal curing. We've been monitoring these for the last 18 months, and the data so far seems to be indicating that the amount of warping or vertical movements in these sections is far lower than the control sections, which were built using traditional mixtures. Now, the advantage of this is that I was talking a little earlier about the need to keep the saw cuts out of the wheel path. And sometimes we've made the compromise of saying, in order to get the joints, the panel sizes, we've had to make the panels a little bit thicker. If we use internal curing, and again, this is experimental, it's still pretty theoretical, but I think it's going to work, is that with internal curing, we can go with thinner sections, still keep the joints fairly far apart, and still keep the joints out of the wheel path. This is a win all the way around, because again, fewer joints means far less maintenance over time. So I've been ranting and raving about all the benefits and the wonderful way these things can behave. Do they actually work? We believe so, and we have good reason for saying that. One of the ways that you can audit this, fact check, this is not fake news. Go to the ACPA website, click on Resources, click on Project Explorers, click on Concrete Overlays, and you'll come to this page where individual projects have been recorded and their performance, how they were built, what they were made out of, where they were bonded, unbonded, what they were put on top of. A huge amount of data are available just on public for you to go and look at near you to see how these things are working out. The overlay market has been growing pretty consistently over time. About 12% of pavements built in the last couple of years has been on overlays. So it's been a real strong part of the industry. It's been built almost nationwide. A couple of black spots of people that haven't, or as far as we know, people haven't played with overlays. And if anybody from those states is listening and prove us wrong, I'd be happy to learn. If you need any help to think about some of this stuff, that's what we're there for, is to provide you with the tools and the resources to investigate this, build it into your toolbox. Just a few photographs of examples. A municipal street placed in Illinois. In this case, you can see not a fancy paving machine, a relatively thin section placed by hand using a vibrating bridge, vibrating screed. performing pretty well. Interstate 70, main line, open space highway in Colorado. Rural Road in Mitchell County, Iowa. This was also an experimental section, first time that we put fibers in, different dosages, different panel sizes. County engineer is very happy with this. And it's not just highways. Airports have been built. An executive airport in Charleston has an overlay on top of it. As far as I know, it's working pretty well. With that, I've done my speech. Dan, you're up. You've got 15 minutes to sing and dance. You need to unmute yourself. There you go.
All right. Thanks, Peter. Can go. There we go. All right. So good afternoon, everyone. I'm going to talk a little bit about the experience that we've had in Iowa with concrete overlays. As Gordon mentioned at the top, as part of the series, different states are going to be sharing their histories and their experiences with concrete overlays. And Iowa's a really great place to start with this because it was one of the pioneering states in the development of overlay technologies. And it was really the first state where concrete overlays saw widespread implementation. As you can see here, there have been over 2,000 centerline miles of concrete overlays constructed since, with some experiments early on, but really since the late 1970s, they started to become a regular part of the system here. I checked, this is a slide from a couple years ago. It's about 2,250 centerline miles as of projects that were completed through 2019. And, it is something that has grown over time. Over half of that total has been constructed just in the past about 15 years or so. And maybe the unique thing about Iowa is that, as we'll talk about, it's really taken hold and become a major part of our rural county highway system. So the majority of these projects and kind of where they were first applied and really took off is when we've seen on the secondary roads. So if ready to go ahead. And then this is the same map Peter just showed a second ago. And this is also from a couple years ago. So as more states have been building more projects, Iowa doesn't stand out quite as much as it does here. But if you click one more time, if you're not familiar with where we are in the US, that's us, covered up by all the overlay projects there. So kind of going back, the first attempts at concrete overlays were attempting to bond concrete to existing concrete. And the sketch on the right there, kind of a concept for an early concrete overlay. Kevin Merriman with the Iowa DOT found that a few years ago. They were thinking about this all the way back, in the 1940s. And I know I've seen from Randy Riley, who used to be the director of the Illinois chapter of ACPA. He's found other concepts for overlays that date back even farther than that. So, the idea had been kicking around in engineers' heads for quite some time, but really it was 1970s where you started to see, at least in Iowa, more experiments go down, and concrete over concrete is where that started. And quite a few of these were built in Iowa over the years. There are some tricky aspects to constructability when we talk about bonding concrete to existing concrete, especially older pavements. So we don't see too many of these projects anymore. Maybe one comes up every couple of years, but that was kind of where things got started. And kind of the dawn of the more modern era for concrete overlays began when engineers started experimenting with what at the time they called white topping, which was just paving concrete over asphalt. That was just basically how they came up with the name for that. And it really was in the 70s when that took off. And county highways has always been in Iowa the main application for these. But kind of the major pioneering project that I think helped prove the concept on this was actually an airport runway in Storm Lake, Iowa. And that was built in 1971. I think that picture's fairly close to contemporary there. And then if you click one ahead, that project is actually still out there in service. It's been patched pretty heavily over the years. And when we were out there, we had a chance to walk this runway up and down in 2017 because it was closed for installation of subdrains. That's why you've got the material piled up on the side of the slab there. But kind of cool that that's actually still out there. And when it's not under construction, they are still using that original white topping project for their main runway out there. What these early designs tended to look like in Iowa was a 6-inch PCC over HMA. And, you know, as Peter talked about, bonding is kind of an important consideration when we talk about overlay design, and it is kind of a, you know, tricky concept a little bit sometimes, especially when you're talking about over asphalt. But with these initial projects that got built out, you know, they didn't consider the bond. They just they knew a 6-inch PCC design would be relatively appropriate for the traffic levels based on experience with full depth paving. So they figured 6 inches of concrete over asphalt should work fine too. You know, again, not worried about the bond, not worried about the condition of the existing pavement. They did find out pretty quickly that, you know, even though they weren't relying on any type of bond or expecting it, that the layers did tend to bond together, and that did probably benefit the performance of a lot of these older projects. But that's where they got started. And then, you know, about another decade later, that's when, at least in Iowa, they began to experiment with the unbonded concrete overlays of concrete. So these existing concrete pavements, putting down some type of stress relief layer. They, you know, tried a few different things. I think there were some projects where they attempted to use maybe a slurry seal or a sand seal type of inner layer, but the asphalt inner layer became the standard. It definitely performed the best out of different concepts that were tried. And like Peter talked about with the geotextiles, now that we have the ability to try this newer technology, since about really late 2000s, that first decade, were the first experimental projects in Iowa. And then really just in the last 6 or 7 years, it's become a pretty regular feature, I'd say, of all the unbonded concrete overlays that are built in Iowa on an annual basis. Half of them still use an HMA inner layer, and half of them are using a geotextile. So it's a pretty regular application now. And then in the 90s, that's when the thin bonded overlays, at the time they were called ultra thin white topping. Now you might, I think in some of my slides here, I refer to them as BCOA, bonded concrete overlays of asphalt, is another term that you'll see in reviewing concrete overlays. But so here is where you're designing them to be quite thin, on the order of, you know, 3 to 6 inches, or even that photo on the bottom right there is actually a 2-inch experimental overlay. So that was only 2 inches thick with those 2 foot by 2 foot panels. You know, in this case, Peter already went over this, but again, you're designing it to bond to the underlying HMA for that structural support. That existing HMA is a critical part of the structural design of the overlay, having that additional structure bonded there. And then you have a pretty common feature of these are, again, those shorter joint spacings to help reduce stresses and curling in the thin slabs. Where Iowa stands today, with the, you know, long history of good performance that the counties have seen with a lot of their projects they've been building over the years, their kind of preferred design is still to build a 6-inch concrete overlay with conventional joint spacing. They'll build unbonded over concrete, and they'll also continue building over asphalt. So in those cases, the counties largely, again, they're not designing necessarily to rely on the bond. It's probably more of an unbonded overlay, but, you know, they do still benefit, I think, from the bond that they get on those pavements. And in the situations, especially like Peter mentioned, in the cities where, you know, your elevation and grade constraints are a lot more critical, that's where we've seen a lot more interest in those thinner BCOA short joint spacing projects, like the photo you see on the right from the city of Lamar's there. That's a city that's built, I think, coming up to close to a dozen different concrete overlays over the past 10, 15 years. So we've seen those, and Iowa DOT has built them both ways. They've applied them to a number of different projects as well. So it's really been a successful application, and you know, there have been quite a few projects built in Iowa, and again, in recent years, even more so than we had seen in the past. But despite this good history, you know, we still had questions that we wanted to answer about this. You know, we wanted to know what kind of service life can we expect if we're building a new PCC overlay, if we're building one of our typical Iowa designs, and maybe, you know, can we characterize a little bit better what type of performance we can expect from the existing overlays that are already out there. So a couple of years ago, as part of the CP Tech Center Iowa Highway Research Board study, we did this research, which I'll just show a couple of slides of results from, but you can find that report on the CP Tech Center's website if you're interested in checking it out. Iowa has really good data for its pavement condition collected by automated vans on their local system, which is great because, again, most of our concrete overlays here are on our local system. And mainly we were characterizing pavements through, a pavement condition index, which is pretty standard in a lot of places. We spent extra time analyzing smoothness as well, since smoothness is one of the most important factors for pavement performance, especially to the traveling public. And then those are a couple of the other elements of that pavement condition index that we use here in Iowa. And just kind of a very quick rundown, since we don't have a ton of time here. Again, the full report, there were breakdowns on all the different overlay types, controlling for things like thickness and joint spacing. But overall, the results really showed, I think, what we kind of had a feel for, given the number of overlay projects that have been successful over the years. But with just all these overlay types together, you can see kind of drawing a line at a PCI of about 60, which is a pretty standard mark for when performance starts to decline. We were seeing kind of an average, especially on these older county overlays in rural areas, about a 35-year, very basic trend line plotted out there. And then the next slide, I think, is the IRI plot. Yep. So here, it doesn't quite reach 170 inches per mile for IRI is one of FHWA's thresholds for when ride quality becomes unacceptable. And so we were seeing, again, pretty similar, about in that 30 to 40 year mark, with a simple trend line plotted out. And obviously you have some projects that are performing better than average, some worse than average, but that's where we were kind of observing the projects that have been built in Iowa to date over the years. And yeah, sorry, the formatting got messed up there. But, overall, we observed, some great performance over the years. And when you do break it out into the different types of overlays, a lot of the different types all performed well, whether it's bonded or unbonded over asphalt, unbonded over concrete. In general, the overlays of asphalt, if you controlled for things like thickness, did perform slightly better than the unbonded concrete overlays of concrete. But that kind of makes sense, because as we talked about, if you do have bond between the concrete overlay and the existing asphalt pavement, you are benefiting structurally from having the asphalt bonded there to that system. So I think that is a finding that largely makes sense. And then in terms of those bonded concrete overlays of concrete, those overall were less successful, but I think in the context of what the design life expectations were, given that the expectations were relatively low for a lot of those projects, in that context, I think we found that those had performed fairly well too. In general, since a lot of these, again, are on county highways that have very similar traffic volumes, you don't have nearly the variation that you do if you have a large data set that you're designing, a lot from interstate down to divided highway, down to rural highway, down, a lot of these were very similar. So in general, the thicker overlays tended to perform better since they were carrying similar volumes of traffic. For the BCOA short slab designs, we had good early performance for kind of the first generation of projects that were at ages up to about 10 years old at the time of the study. So that was positive to see. Not as much long-term data there, obviously, but the older designs with conventional joint spacings had performed well over longer periods of time too. And then, like I mentioned, traffic, most of these were on low volume county highways. They'll see a decent amount of trucks as a percentage of the total traffic, but overall, it's hard to, find overall trends relative to traffic volume when most of the projects are kind of in that same category. And so, kind of some of the takeaways from the history and experience that we've had in Iowa, your design life expectations are always going to be in the context of, what type of design you use, what your existing pavement condition is, and things like that. But certainly for the types of overlays that are commonly built in Iowa, certainly we found that we can expect those to last on the order of 30 years, and that county highways in particular are a great application for them. But where the DOT has built them in higher volume applications, and where cities in Iowa have built them out as well, we've seen good success on those projects too. So kind of as Peter mentioned, the goal, I think, with building or kind of beginning to use concrete overlays as one of those tools in your toolbox from a pavement design perspective, that's kind of what the Iowa experience has borne out over time, is that as all these agencies experimented, they got designs they, began to become comfortable with, and they had a lot of experience, and obviously the base of contractors got used to building them. It really did start to become a commonly seen thing, and we usually see probably on the order of a dozen or more different counties in Iowa each year with at least one concrete overlay project. So it's really become a regular part of the pavement network here, which is great to see. And I think as concrete overlays, do see more usage in other states as well. I can imagine, like Peter showed that national graph of growth of projects, starting from a very small percentage of all pavements nationally up to about, I think it was 12% in recent years. In Iowa, that number has stabilized recently, probably at about 20–25%. So really just that experience helps drive, it helps it become, again, a regular tool in your toolbox there. So, and just a quick comment here, since, one of the other takeaways when you do a performance history is if you look at, you're plotting trend lines for these large groups of projects and things like that, but kind of as a last lesson learned and maybe a takeaway and a motivation to continue to do what we can do to do things better, is that this gray trend line you see plotted out here, this was for a subset of projects in the study. That gray trend line is the performance trend, including all of the dots that you see plotted out here. But one thing we did to kind of show, in terms of we always want to do things to improve, our design practices, improve our construction practices, use better materials and things like that. We separated out kind of the poor performing project outliers that Peter's pointing out there in blue at the bottom, and just plotted if we did everything great, the projects in orange that are performing well, relatively well, you can see, we could stand to see, even more improved performance. So again, just, in terms of why do we have things like the performance engineered mixtures program? Why are we always trying to improve construction practices? You can see here, if you can, kind of eliminate those, bigger problems or where things don't go as well, you would stand to see a lot of room. So kind of a motivation to, keep doing what we can do to improve our practices and design, things like that. So with that, I'll kick it back over to Peter to wrap it up.
Sorry, I was on mute. Thanks very much, Dan. Just one more slide that I've got is, again, there is an abundance of material available, but the ones to highlight on our website, and here's a screenshot of that website in the middle. The URL is on the bottom right. We will be emailing out a link to this at the end of this session. One of the books we would refer you to is the guide manual on concrete overlays. It's got all of this information and far more. We're in the process of actually rewriting this document, but this is what we have available to you right at the moment. And with that, I'll ask Gordon to start reading questions.
Thank you, Peter. Good to be back. I got the questions up here, and I think maybe what we'll do is just get started on them, kind of run through what we're seeing. There's a few here that are comments about some sound issues and stuff, and we will continue to work on that to see if we can't improve that in the future. And I know there were several people that were losing connections, and I don't think that was necessarily on our end. That may just be internet issues, and I know that a lot of people have had some difficulties with the internet recently with all the traffic that's on it. One of the questions is, will there be PDH certificates? And yes, we will be doing that. We're working, we'll provide those to you. We're also want to thank ACPA for all the work that they've done in getting the word out about this, working through the ACPA in Chicago, and then also the ACPA chapters and state paving associations around the country. We have been collaborating with them to make sure that we can get this done and get something that could be useful to use. So, all right, I'm looking on down through here. There was a question, are there any repair methods that should be avoided hang on a minute, should be avoided in the interest of future concrete overlays, materials or methods? Peter, is that one you want to handle or
Not really.
Start on anyway?
I think you probably know more about that than I do. I guess I would qualify the question: repairs to overlays or repairs to the base, the existing pavement system.
My general thought is it's probably repairs that we were talking about with regard to the existing overlay itself. That's been pretty wide open as far as my experience has been, is that we go in and do a typical patching. Actually, on some of the concrete overlays on asphalt, I can think of a couple projects, especially airport projects, where we did some patching on those with just a Econocrete type mix, or a slurry mix that we could use just to fill up the joint, so we didn't get keying on the project and between those existing joints that may have opened up quite a bit on those old asphalt pavements. So I don't know that, there's certainly opportunities with some of the, depending on the type of project you're using, with regard to some of the newer products that are out there, fast setting projects. I have not heard anything that's really been detrimental as far as using some of those for overlay repairs, or for the repair prior to placing the overlay. And so I think we've not really seen too much at all in that regard. Next question is residential settings in the curb line compromise when the overlay goes over that. A lot of the curb line work that we've done has probably been more removal of that curb, but we have seen some incidents or some occasions where we've gone in and done the curb treatment similar to what Peter had showed in that project, or in that slide that he had. And I think in general, those have worked pretty well. Those were kind of a bonded concept. The other thing that we have done in some instances where we've actually gone in and milled down in that curb and gutter zone, so that we could just butt the overlay into the side of the existing curb, and we've had pretty good success with that as far as the projects that I've been involved with over a number of years. So, okay. Bear with me for a minute, as I'm having trouble trying to get this opened up so I can see it very well. All right, here's the next one. If asphalt pavement shows signs of stripping, how should this be considered in choosing bonded or an unbonded overlay? My answer to that, and I'll see if Peter wants to add to it, but my answer to that is that if you see a significant amount of stripping in that existing asphalt layer, it may be that you need, if you think that you would like to depend a little more on the bonded aspect of the overlay, you probably would have to see if that was just lift oriented. If it were just the lift, we might want to take that lift off. If it is not just the lift, it's the system itself, I would probably err on the side of considering an unbonded approach to that, or just concrete on asphalt, and you may get some bond and you may not. The other thing is, if we've seen some instances where there's been a not only from the stripping standpoint, but also from the standpoint of just lifts of asphalt that are moving. If you've got that, you really need to address that, because I think that would be a problem on down the road, in our experience anyway. Peter, did you want to add anything?
Yeah, I'd actually be a little bit more negative about it. Is that if the existing asphalt system is stripping, I think you've got to pay attention to the drainage system as a whole, because if it continues to strip with the new layer on top of it, you're going to lose support. So deal with the stripping well before you think about putting an overlay on it. That would be my warning.
Okay. Next question I have: in bonded PC over HMA, the existing asphalt must be thick and in a fair condition. Could you please be a bit more specific about the HMA thickness and condition?
I think the guidebook gives a minimum of 3 inches. I know there is one state out there that is happy with using less than that, but I would preface that on, again, what is that asphalt sitting on? But as far as I'm aware, it's 3 inches is a bare minimum.
Right. And I think one of the things that I've observed in that over the years, and you're right, the guide as it stands right now does say 3 inches a minimum. And when you get into certain parts of the country, especially where you've got the freeze thaw and that type of thing, I would be a little reluctant to, unless it was the existing asphalt pavement was built on a very substantial granular sub base or asphalt base type of thing, I would be reluctant to probably utilize that if it were less than 3 inches. And because I think what we've seen is a lot of concern sometimes, and of course part of that's because we do a lot of the low volume roads where we get the truck traffic or the construction traffic on those thin asphalt layers, and sometimes they will create problems, as far as failure of that asphalt. Now, if you've got the room and you're building on interstates and that type of thing, you probably it's a little bit different animal because you've got shoulders that you can work off of and that type of thing. But I think that the moral of the whole story there is you've really got to kind of understand what kind of support. And if it's a 2-inch thick asphalt on top of a very healthy granular base and it's performed well for a number of years, then and it's not moving and doesn't seem to be doing a lot other than maybe just some surface concerns, it probably is one that you can consider. There's got to be some judgment in all of those. So, okay. I believe, let me scan here again just a minute. That's about all. Hang on. I got 2 different screens. Please bear with me. Okay, here's another one. Even if we provide a geotextile as a bond breaker, we may not still prevent reflective cracking. It's a possibility if the geotextile is not addressing the faulting aspect and you may be getting some keen, I think you could certainly get reflective cracking in that condition. I have not seen examples on pavements where we did not have faulting problems where we use a geotextile that we had any significant reflective cracking at all. I know that sometimes in asphalt overlays that does happen, especially if you're putting an asphalt overlay and using some type of a fabric on a concrete pavement. I have seen that happen, but we have not experienced that to any great extent in concrete overlays that I'm aware of. Peter, you want to add anything, or Dan?
I'm not aware of any issues.
All right. Okay, the next question, how important is density when using a thin asphalt overlay as a bond breaker?
I have to get you to answer that one, Gordon. I'm a concrete.
Okay,
Yeah.
I think you certainly want to compact the bond breaker. One thing that I know we had some experience up in Minnesota where they were using a rather open graded type of material in the asphalt and probably did not have the density. We saw some additional stripping and that type of thing in that pavement. So I think in general, we want to have a good dense base.
All right.
Okay, disregard, you covered it. I'm scrolling down through here. All right. There's still several that we've got, Peter. I would suggest maybe we go ahead and try and answer these and get it out to everybody so that they can all enjoy that. I've talked to Scott and he's willing to work with us on getting that information out. And I would also want to mention again that we are going to rebroadcast this on Friday at noon. Again, we understand it's a Good Friday and some people are not working that day, but we're going to go ahead because we've got a pretty busy schedule next week. We'll go ahead and broadcast that, but then it will also be available on the CP Tech Center website, and it's at cptechcenter.org. You can drill down into that and find it. We'll also be, ACPA and ourselves will also be sending out a notice to you about those details so that you can access that. If you know of people that were not able to get on today because of the limitation, please let them know about the rebroadcast and the availability. We're going to try and address that a little more next week with the hope that we continue to get a large group, and but we'll make sure that we've see if we can't have more room for everybody to get in the room and still be distanced the way we need to be, right? So anyway, Peter or Dan, have you got anything else that you want to add?
Again, thanks to everybody that's signed on. Feel free to contact us if you have questions. Feel free to log on to the website and explore the resources that we have. And we hope to see you same place, same time next week.
Thank you, everybody.